Hey guys, welcome back to my channel. I hope you got curious about last video. As we told in our last video, this video will be about the Big Bang and theories around it. So, let's get started. According to the conventional Big Bang theory, the beginning of the universe involved a singularity, a region of infinite temperature and density whose nature is difficult for humans to understand. However, because the singularity theory is based on Einstein's theory of general relativity, scientists believe that this may not correctly reflect reality. The origin of the cosmos is still mostly unknown. A trillionth of a trillionth of a trillionth of a second after the Big Bang, according to scientists, is where the story may be picked up. Scientists believe that the universe went through a spectacular and extremely brief era of inflation at that time, expanding more quickly than the speed of light. Within a few tiny fractions of a second, it doubled in size, possibly 100 or more times. The theory of special relativity may appear to be broken by inflation, but according to researchers that is not the case. According to special relativity, nothing can travel faster than the speed of light between two locations in space. However, inflation actually caused space to grow. According to an idea, this quickly expanding universe was essentially void of matter but was filled with dark energy. Scientists believe that a mysterious element called dark energy is responsible for the universe's present accelerated expansion. Dark energy caused the universe to accelerate and smooth out during inflation. But it didn't stay for long. Scientists are unsure about the possible causes of inflation. That is still a crucial query in Big Bang cosmology. The majority of cosmologists believe inflation to be the best hypothesis for describing the properties of the universe, particularly why it is homogeneous and relatively flat, with nearly the same amount of matter distributed evenly in all directions. There are several theories that attempt to explain the structure of the universe in addition to inflation. Another theory, known as the cyclic model, was developed by theorists and is based on an earlier idea known as the ekpyrotic universe. According to this theory, our world did not form from a single point or anything like. Instead, it jumped from a pre-existing cosmos that had been contracting into expansion at a significantly slower rate than the inflation theory predicts. By this theory, the universe has likely gone through an infinite number of bangs and crunches. First, however, how did our cosmos emerge from nothingness? According to cosmologists, the four fundamental forces of the universe, gravity, electromagnetism, the weak and strong nuclear forces, were likely compressed together into one force at the time of the universe's creation. However, as the cosmos cooled and expanded, things altered. It's likely that the strong force split off around the period of inflation. After the Big Bang, the electromagnetic and weak forces also separated. Roughly 10 trillionths of a second later, the universe was probably filled with a hot, dense plasma just after inflation. However, scientists believe that by 1 microsecond or so, it had cooled sufficiently to permit the formation of the first protons and neutrons. These protons and neutrons started fusing together 3 minutes after the Big Bang to create deuterium. Then, deuterium atoms joined forces to create helium. The universe was yet too hot to allow for the capture of electrons, thus all of these newly formed atoms were positively charged. However, 380,000 years after the Big Bang, that situation changed. Hydrogen and helium ions started snatching electrons and creating electrically neutral atoms during a period known as recombination. Significant light scattering occurs off unbound protons and electrons, but considerably less so when light strikes neutral atoms. Photons might now travel through the universe with far more freedom. Recombination significantly altered the appearance of the universe, from being an impenetrable fog to becoming transparent. This epoch is when the cosmic microwave background radiation was present. But even after recombination, the cosmos remained quite dark for a while, only fully coming to light approximately 300 million years after the Big Bang with the appearance of the first stars. They contributed to undoing much of what had been achieved via recombination. The radiation emitted by these early stars, and possibly some other unidentified sources, was sufficient to divide the majority of the hydrogen atoms in the cosmos back into protons and electrons. Around 1 billion years after the Big Bang, the reionization process, also known as ionization, appears to have reached its conclusion. The cosmos has expanded so big that it is no longer as opaque as it was before recombination. According to scientists, the universe's matter is extremely diluted, making photon scattering interactions relatively uncommon. The universe became increasingly more structured on a big scale as a result of the gravitational pull of stars coming together to create galaxies. Around some freshly formed stars, like our Sun, planets began to form. And life began to exist on Earth 3.8 billion years ago. So, that's all about the Big Bang. I'll meet you in another video. Until then, this is your S&S signing off.